So I'm going to talk about these main three trigonometric function: sine, cosine, and tangent. And I'm going to talk about some formulas um, about these three trigonometric function detailedly. And at first, in order to, we can only apply this three trigonometric function when the triangle is a right triangle. So I will describe it by writing these lengths and size. At first, the sine of 60 is equal to opposite, which means x. So x will go here over hypotenuse, which is hypotenuse here, h. And for cosine, cosine 60, it's gonna be adjacent over hypotenuse. And if you look at this 60 degrees, adjacent side is right over here, which is y. So I'll write y here, y. Over hypotenuse, same thing, h. And for tangent 60, let me erase this. For tangent 60, it is opposite over adjacent, which is different with sine and cosine. So opposite side, which is x. X over adjacent, which is y. And we have finished some expressions and formulas about sine and cosine and tangent. So if I review it, it's sine of something, I just put 60, but sine of something is equal to opposite side over hypotenuse. So I did opposite side over hypotenuse, which is x over h. And for cosine of something, it will be adjacent side over hypotenuse, the longest side in the right triangle hypotenuse. So it'll be y over h. So for tangent 60, it's gonna be opposite over adjacent, which is opposite side x over adjacent side y. So we are done with this three trigonometric function, and we are done. So the question is find the value of length AB, which is this side AB, and round your answer to nearest hundredth place. At first I'll just call AB H, CA X, and CB Y. And the main point of this question is we need to use trigonometric function, which is sine, cosine, and tangent in order to find the lengths. And we can only apply this trigonometric function when the triangle is right triangle. So I'm gonna review the trigonometric function a little bit in order to choose one of these trigonometric function in order to solve this question. So let's see for the tangent first. For the tangent, it is opposite over adjacent. So from 25 degrees opposite, which is 2, and which is y. That means y over adjacent x. But we don't know the value of x, so we can't apply tangent here. For cosine, it is adjacent over hypotenuse, adjacent over hypotenuse. We can't use cosine either because we don't know the value of adjacent side. We also don't know the value of hypotenuse. So let's see the sine. It is opposite over hypotenuse. So opposite over hypotenuse, opposite side is y over hypotenuse, h. We don't know the value of h, but we do know the value of y, which is 2. And that means we can solve for h using equations. So if you were to make equation for this problem, it is sine of 20 is equal to opposite side, which is y, and we can replace it with 2. I'll write in different color. 2 over hypotenuse, which is this value, and we don't know it yet, so I will put it as a variable h. But we need to remove this h and leave it in the left side. So we to multiply h in order to isosceles h into the one side, which is left side, in order to solve for h. And if we multiply h to the right side, we also need to multiply h to the left side to keep this equation equal. So this is our first step. And this h will cancel out, and it will be h times sine of 20 is equal to 2. And we can divide sine of 20 into both sides to isolate h to the left side. And the result of this equation will gonna be h will gonna be 2 over sine of 20. Oh, sorry, 25. And I already calculated the value of 2 over sine of 25, which is 5.22. I'll just I'll just post it here. It is 5.2262586, but in the question, if you read it carefully, it says round your answer to nearest hundredths place. So we can round it in the hundredths place, which will give us approximately 5.23. So the answer h value is approximately 5.23. So we use sine, which is one of the trigonometric function, which is proper for this question. And so the answer was approximately 5.23. And in step 1, we made an equation for this triangle. And in the second step, we isolated h, simplify and remove all the sides and put it to right side, and you will left with the third step. H is equal to 2 over sine of 25, and we calculated 2 over sine of 25, and it will be approximately 5.23, and we're done. So the question is find the value of length AC, which is AC, and round your answer to nearest hundredths. At first, I will call AC X, and I will call CB Y, and I will call ABH. And before we solve this question, we need to apply trigonometric function, because we can only apply when it is right triangle. And so let's review some trigonometric functions, sine, cosine, and tangent, in order to apply one of those in this triangle. So for sine, it is opposite over hypotenuse, which is opposite side y over hypotenuse h. And it should be y over h. But we can't solve because there is no opposite y value. So we can't apply sine in this triangle. So let's say tangent. For tangent, we can't also apply it to this triangle because it is opposite over adjacent, but we don't know the opposite value of y. So for cosine is adjacent over hypotenuse, which is adjacent x value over hypotenuse h. So x over h. Even though we don't know the value of x, we know the h value, which is 2, so we can solve for x. Okay, so if you make equation, it's gonna be cosine of 20 will be equal to, it will be x over h, which is x value, we don't know it, so we'll just leave it as a variable, over h, hypotenuse, which is 2. And we need to find x, so we need to isosceles x in the right side. So that means we need to remove all the expressions to the left side, so we can multiply 2. So this term will cancel out, and you will left with 2 times cosine of 20 will be equal to x value. And I already calculated 2 times cosine of 20 values, but so it is 1.902113033. And if you look at the question carefully, it is round your answer to the nearest hundredths place. So that means we need to round it nearest hundredths place. Is 100 place and this thousands place, and you will give us 1.90 or just 1.9. So this value of x is approximately 1.90. I just used cosine value which is suitable for this triangle. And for the cosine, it was adjacent over hypotenuse. Adjacent over hypotenuse. And in the first step, we made the equation in order to find the value of x. And for second step, we removed every expression in the right side to the left side in order to isosceles x in the right side, in order to find x value. And we calculated this expression 2 times cosine of 20, which will give us approximately 1.90. So the answer is x is approximately 1.90. And we're done. So the question is find the length of AC, which is right over here, using the given angle and the size. And first of all, we need to know, we need to make decision whether we use what trigonometric function for this triangle. So let's review trigonometric functions a little bit, and I assume you guys to memorize it. So that's the reason why I keep doing these things. To make it a little bit smaller. Okay. So trigonometric function. So let's see sine first. For sine, it is opposite of hypotenuse. So opposite, which is 3, over hypotenuse. But let's say h. I will call this length x. I'll call this length y. And I will call this length h. So it should be 3 over 8, which is opposite side over hypotenuse. But we are not finding hypotenuse value. We want to find the value of x, so we can't use sine. For a cosine right over here, it is adjacent over hypotenuse, adjacent over hypotenuse. Also, we don't know both value of both adjacent and hypotenuse, so that means we can apply cosine for this triangle. If you see tangent, it is opposite over adjacent. So if you look at this, it is opposite side, which is 3, over adjacent side, x. So finally, that means we can apply tangent for this right triangle. So if you were to make equation for this, we can make like this. Tangent of 25 is equal to opposite over adjacent. Tangent is opposite over adjacent, as we can see here. Opposite over adjacent. And opposite side is right over 3 over adjacent side, which is x. And we can multiply x to both sides in order to isolate this x and remove all the expressions. And this x will cancel out, and you will left with x times tangent of 25 is equal to 3. And let me do here because we don't have really space. Tangent of 25 is equal to 3. So we can divide tangent of 25 to both sides. And you will left with these terms will cancel out. And it will leave us x is equal to 3 over tangent of 25. And this next step is will going to be this one. And if we calculate it, let me do here. 3 over tangent of, let's see it again, is 25. And the answer will going to be, let's see, if I calculate 3 divided by 25 tangent is equal to 7.242, sorry, 426 and so if you were to round it nearest hundredth place, and it will leave us 7.24. So the x value here will be approximately 7.24. And so for this triangle, we use tangent which is one of the trigonometric function, and tangent was opposite over adjacent. And for the first step here, we made equation in order to solve for this triangle. In the next step, in the second step, I tried to isosceles x value, same thing here, in order to make it equal to an expression to simplify easily. And then I calculated 3 over tangent of 25, and it will left us x is approximately 7.24. So the answer of this question will be x is approximately 7.24. And we're done.